today's introduction to STL. STL stands for Standard Template Library. Uh, and if you remember from previous class, we have studied two type of templates, and I hope some of that idea will help you here. Okay, even though we are not going to design something new now, we are just using already the written code in the standard template library. But if you remember, we have studied a function template and class templates. So actually, this is also one of the template like that, but this is just to help the programmers and support the programmers and to use uh, different functionality in easy way. For example, you see the standard template library offers vectors. Okay, so vectors is a data type in which we can store values like array. Okay, but vectors are much more easier. You will see later on, we will run some examples. Much more easier and much more flexible as compared to array, and which in many way is superior to standard array. You see, like vector are superiors from normal array because it's very easy to read and write values to their apply operations. Okay, you will see this one how vectors are uh, better than array. So you see these vectors are defined in the standard template library. Okay, and not only this vector, actually there are several containers. So this is called actually container. You know, the vector and the array, these are containers. They are storing values. Okay, so there are three or four different type of containers which are defined by standard template library. And another category of functionality in STL is iterators. Iterators are like loops. Okay, to iterate in the container and to access the elements inside the container, or to write elements to the container or read values from the container in an easy way. Okay, these are called iterators. Okay, so STL has two main things. One are containers, different containers. One of them is vector and iterators. uh, I don't think so that we have enough time to cover everything in STL also, because it has many several containers and then iterators, and not only containers and iterator. Third categories are algorithms. Already written algorithms are there. Like algorithm means, like, if you want to search the array. Let's suppose if array is of thousands of elements, so how to quickly search, search in ascending and descending order. So there are different algorithms for sorting, and unfortunately we couldn't cover that one, and that is not a part of our syllabus also. But if we got time, then we will study that one, like binary search, bubble search. Okay, so there are several different type of search. Okay, these algorithms are also part of standard template library. Okay, but note another one point, that this standard template library is not part of C++ language. It is written by third party programmers, and after testing and verification, it became a standard template library, and now you can include to C++. Okay, so it is not part of C++. It can be included and you can use it. Okay, so what I told you, all these are here. Okay, now look, to use a container whose name is vector. Not the point. Vector is a container. Okay, it contains values like array, and you know we have already studied array. So if you want to use vector in your program, then you will have to include this header file, hash sign include, and in the angle brackets vector. And you will must use the using namespace std also, because this is defined in the namespace standard namespace also. So using namespace std and include vector. Now if you want to define a vector container, if you don't understand this, then you think like this. If you want to define an array, okay, but here is not array, here is a vector. So if you want to define an array, okay, alternatively, whenever I'm using the word vector, if you are confused, just think vector is like an array. So vector array, just think like that. Okay. Now, if you remember in C++ when we were defining array, so it was like this. Like let's suppose int, okay, then the array name. Let's suppose any, you can give any name. Let's suppose array one, and then there was angle brackets, and in the angle brackets we will have to specify the size. Like let's suppose 6. So we were defining array like that. Now the difference in vector is like this. You see, use the word vector, then like here, what type of value you want to store in the angle bracket, use that value, that data type. This word, this angle brackets will may remind you the class template. If you remember, in our last class we defined class template, but when we were creating object of that class, then it was exactly like that. Okay, object. So previous at that time here was our class name, but now is a vector. So you can think like this word vector is also like a one class, one template that someone has been defined. Okay, so vector, what type of values you want to store in, just put in the angle brackets. This int doesn't mean the size of vector, no, the type of vector, and this one is the name of the vector. Okay, like here is the name of array. So vector, angle bracket, integer, and its name is number. Okay, you see in a vector, this is one difference, that array you cannot define without size, but vector no need to define a size. Okay, why? So you see, this is the difference between array and vector. Why? You see, if we don't define any size of the vector, it means that vector is resizable. It can expand automatically. Its size can increase and decrease automatically. Okay, so you see, it's like dynamic in nature, but array is static. Whatever size you define, you cannot increase, you cannot decrease. But this one, you can add as many values as you want, you can remove, so its size can increase and decrease. Okay, if you still want that, no, I want to specify the size, you can like this. You see, vector int number, this will be the size. Note again the difference. In case of array, we are using brackets, but in case of vector, we are using braces. Okay, not brackets like this. So this is another difference when we were defining array. Sorry, yeah, in array we are using this, and in vector we are using braces. Okay, next difference is if you want to initialize array. Okay, previously we were initializing array like this. If you remember, int, for example, score equal to, and then in the curly bracket we were here must be the brackets. So it's up to you if you want to specify size or no. But if you don't specify size, the size will be automatically the equal to the number of values that you defined here. Let's suppose like this. So this will be array of size 3 and its values are 1 to 3. In the same way, if you want to initialize a vector with specific size and with specific values like this, then you see is like this. Vector int, its data types are integer, its name is number, its size is 10, comma, the other value 2 means that all the 10 locations, it will be exactly like array. Okay, it will have 10 locations. Okay, 10 locations, but every location will be initialized with the value 2, 2 here, 2 here, 2 here, and so on. So this is another difference from array. Okay, another difference from array is that if you want to initialize one vector from another vector, which already have values in, so you just want to initialize from any existing vector, then you can do like this. Vector int set 2, this will be the newly created vector, and it will be initialized with the values from an existing vector whose name is set1. Okay, you see, this is another difference and facility from array. in array you cannot do like this. Simply you cannot do like this, that one array equal to another array. No, you cannot do. You cannot initialize like this also, that int score equal to another array. No, you cannot do. You see, from this perspective, array has a lot of limitations. Okay, but vector is really nice to use. I love it. Yeah, it's really nice. Okay, so easy to use. Okay, next one. These are the different functions, are the different ways that we can use. For example, if you want float type, its name will be this. String type, the array name, the vector name is this. Int, vector int, integer type, its name is scores, and its size is 15. Vector, its type is character. Okay, its name is letter, its size is 25, and each location is each location is initialized with the value a. Another one, vector double values. So you see, this one is a double of type double. Its name is values 2, and it is initialized with an existing vector whose name is values 1. Okay, so these are the different ways that you can create different type of vectors. You can initialize, you can fix the size, or if you want that no size at the beginning, then okay, just skip like the first two. Okay, and in this way you can use. So you see, this one is so flexible. Sometime we don't know in advance that how many values we need to store. For example, let's suppose a business don't know that how many customer today will come. They don't know in advance. So if they want to create a container to store all the customers name, then they don't know in advance. So if you are using array, so you will have to estimate maybe sometime too big size, that if let's suppose that number of customer didn't came, then you waste the memory. The meaning to say the big size is not utilized. And if you initialize a small array and the customer came more than that, then you cannot extend the array. You will have to redefine another new array. Okay, so that are the limitations. So you see, vector solve all these problems in a very nice and easy way. Another point you see here, that using an initialization list with vector in C++. You see, C++11 introduced this one also, that you can initialize with a list of values like this. Okay, you can provide a list like an array, but not the point. Not the point. Here is no equality. You see, no equality. Yeah, so you will not use equal sign. Okay, like in the case of array. Here, no need. Okay, no need to use array. Sorry, no need to use the equal sign. The rest is the same. Vector int, the vector name, and curly brackets, and how many values you want to provide. Okay, so this is another way to initialize a vector. Otherwise, if you use just two values, like in the previous example was 10 and 2, then the 2 means that every location will have the value 2, which is actually not so practical value. Practical, maybe this one is much more practical, because every location should not have the same value. Okay, now to store values in a vector and retrieve values back from a vector, this is an example. Let me show you this example practically. This example is which one? 7.24. So 7.24, this one. Okay, you see at this one, the vector header file is included using namespace std, because we are using this from very beginning. Otherwise we cannot use the cout in this style. Okay, now line number 10, the first one is just a constant value, value, because we want this constant value later on to use in the size of vector. So line number 11, vector int hours. So this will be one vector and its size will be 5. Okay, so a vector of size 5, its name is hours, and another vector of type double, its name is parrot, and its size is also 5. Actually, this program is like number of employees, they are working for some hours. So what will be their total pay or total amount? Okay, this program is totally for this type of problem. Now this is index variable just to use in inside the loop. A message to user that enter the hours worked by imply. Okay, we imply, meaning to say, you see that the number of employee is 5 by the 5 implies, and cout implies at their hourly rate, meaning to say enter the number of hours of 5 implies and their hourly rate. Then use the index variable in the for loop. Index equal to 0, index less than number of values, index plus plus. Okay, and you see here is again a message and the values. You see, note the point one thing, that when we are using values inside a vector, then at that time we are using the brackets. You see this bracket like an array. So ours is a vector, this index is the variable that we defined here, and it is the loop variable now. And to use a specific index, you see we use this type of brackets. And again another message. Okay, and the hourly rate index, again another vector and its index. So in this way we enter all the values to the two vectors, and here actually almost the same thing, but we are reading back, we are displaying the values from the vector. For index is the same variable that we defined here, equal to 0, index less than number of implies, index plus plus. So here is just calculating the gross pay. Gross pay is equal to what? Gross pay is the hours, that how many hours you work. For example, you work 8 hours a day, and each hour your rate is, let's suppose, 50. Okay, so 8 times 50 will be your full day gross pay. So it is exactly like that. So the first value in the hours and the first value in the pay rate. It is also possible that you have 5 employees, okay, and they work for different hours. Let's suppose the first one work 3 hours, the second one work 6 hours, the third one work 10 hours, something like that. So this is why hours vector and the first value in that vector and the pay rate, and maybe all these 5 employees are not of same level. Okay, maybe some employee have a high salary, some has low salary, so each employee have different rate. Let's suppose this one has 50, this one has 20, this one has 100, let's suppose something like that. So the first value for number of hours in hours vector, and the first value in the pay rate for the rate value, it will be multiplied with each other, and that will be stored in the gross pay. Okay, and then you see index plus 1, because indexes start from 0, so it is not a good message to display that the gross pay of 0 employee is this one. No, the gross pay of employee number 1 is this, the gross pay of employee number 2 is this, and so on. So the whole program is about this. Okay, so let me run. Okay, to run this program, you see it will display a message now that hours work by employee number 1. So the employee number 1 worked, let's suppose, 5 hours. Okay, 5 hours, uh, and the employee number. Okay, and what is the pay rate of this employee? Oh my gosh. Okay, the pay rate of this employee is, let's suppose, 20 ringgit per hour. Employee number 2 worked 6 hours, and its pay rate is 30 hours per hour. Third one worked only 7 hours, and its is 70. 4 8 hours, and it's, oh, it is getting a lot, 60. Okay, So 5 1 should be 9. Okay, this one should get more. So it has 100 per hour. So you see, this was the first loop that we enter the value, and this is the second loop to display the values back. So here is the graph paper for each imply. Imply number 1 has 100 because 5 multiplied 20 is 100. The other one is 180, 280, 480. Wow, the imply number 5 is earning 900 per day. Okay, so the vector works like this. Next one is, yeah, this is the output of this program. Next one is a range based for loop. If you remember last time and even in the previous example, we were using for loop like this, that for int index equal to something, comma, index less than some value, index plus plus. So you see, for loop was having three parts. That is not the range based for loop. A range based for loop is such a loop that actually the loop understand the size of container automatically. Okay, and the loop will iterate automatically until the size of the container. Okay, another difference between vector and array is that actually array don't know about its size. Okay, array can't maintain its bounds, lower bound and upper bound, but vector know about its size. So even you can call the size function. Later on we will study size function. So vector know about size. So if vector know about size, then the range for loop can utilize this property, and then can use easy way. So if you look at this one, you see, or maybe I should open in Android in a Visual Studio Code. You see, it is quite easy. You see, a vector of type integer, its name is numbers. It has values, 5 values, 10, 20, 30, 40, and 50. Okay, initialized like this. Note the point, there is no equal sign. Assignment operator. There is no assignment operator. Now look at the easy way of for loop. I really like this one. You see, for int, value, and numbers. You see, the for loop is not like this, that for int value equal to this and value less than equal to this and value plus plus. No, it automatically initialize. It will iterate until the size of this vector. The main thing is that you see, the vector know about its size, meaning to say that the size of the vector is accessible. Therefore the for loop know how much I should iterate. Okay, so value colon numbers, meaning to say the first value from the number will be copied to the value and then display. Next value, then display. Next value, then display until the end of uh, the vector. Okay, it's so easy. It will display very easily like this. I think I didn't save it. Let me save again. Now run. Yeah, you see, 10, 20, 40. So easy. The loop is now so easy. So note the point that C++11 has a range based for loop. But note the point that range based for loop can only be applied on such container whose size can be identified, who know about its size. Array cannot, normal array don't know about its size, so we cannot apply range based for loop there. Okay, so next one, how to use this one. We are using in the same range based for loop, but we are using reference variable. So once you use a reference variable, then you can even enter values to the vector. Here, if you see this one, this value, int value, this is normal integer variable, so we can only access values. We can only read values from the vector. We cannot insert to the vector using this variable name. No. If you want to insert in this style, then you will have to use a reference variable. And if you remember, reference variable is such a thing, such a mechanism that, let's suppose you have an array and this array has some size, okay, and now you create an integer variable, okay, but reference variable, not the point. Reference variable is always with address operator. Pointer, don't confuse with pointer. Pointer is always with asterisk, with this one, okay, with this one. So address operator, let's suppose value. Now this is a reference, so it can store an address. So if you assign the first location, let's suppose this is mm, score vector, okay, and if you assign a score 0, okay, then address of score 0, then this variable and this variable both pointing to the same location. So any change here will occur here. So in this way, when we use a reference variable, then if we change value in the reference variable, it will indirectly change the value here. So this is why another way to use a range based for loop to enter values to the vector, we can use a reference variable, and that is like this. You see here the same vector of size 5, but previously, if you remember, you see previously we initialize, we give the value at the beginning. Here we are not giving values because we are using range based for loop, but we are using a reference variable, okay, a reference variable. So note the point, if you remove the address from here, okay, the address operator from here, then it will not enter the value. If you see here, we are using cinval, so we are entering the value to this variable, not to the number. But if you use address operator, okay, it means enter the value to the place where this reference variables point to, and we know that this reference variable is pointing to this. And note the point, another point, that name of a vector and name of an array is actually a pointer. So if you see here, we didn't use the address of like this. Why? Because name of a pointer, a vector, and name of uh, array by default is a pointer, meaning to say it represent, its name represent the first memory location to the sequence of locations. So it represent a memory location, and memory location is what? It is address. So the address of first memory location assigned to this. So any value assigned to this, it will assign to the first memory location. In a for loop, change to next one, then the same variable will point to the next memory location, and the value entered to that will enter to the next memory location, and so on until the size of vector. Okay, in the same way, you see this time we are reading back values, so reading back, no need to use reference variable. Okay, we just want this variable to use only here. We don't want that this value should reflect back to the vector. This is why no need of reference variable. I hope you understand the difference between normal variable and reference variable in this range based for loop. Okay, if I run this one, okay, it will ask for values. Enter an integer value, let's suppose 1, another 2, 3, 4, 5. You see, and the values that we entered, it's basically they were stored in the vector, and later on you see the for range base, the for loop is accessing, you see, the same values from here. So it means the values actually went to the vector. Okay, actually went to the vector. Okay, okay, next one is, okay, next one is a function that one enter a new value to the vector. You know that, you see here, this pushback function is working like this, that let's suppose you have a vector of size 4, 1, 2, 3, and 4. Now you want to add a fifth value. You see, it is already ended, it has only 4 values, but you want to insert a fifth one. This pushback function will do what? It will create another fifth location for you at the end, not the point, at the end. This is the start, okay, and this is the end of the vector. It will insert a new item at the end of the vector here. So you see, this is another difference in from array, that we can dynamically add new values. So now the size change from 4 to 5. If you call this function once again with a new value, it will create another new location and the size will change, and so on. It's up to you, as many values as you wish or as you need, you can add this one. So pushback function add a new value to the vector at the end. Okay, this program is showing this process. So let me show you this one. You see here, now the same example, the hours, the period, the imply, okay, but you see, previously, if you remember, there was a constant variable that we defined, and we defined the sizes, you see, previously. Now no sizes, no constant variable, because using pushback we can insert new values. So here in this loop, you see, we are just push back a value and new value, and push back a new rate. Okay, so in this way, just push back, call the pushback function, it will add a new value at the end, next one at the end, like a queue. Okay, note the point, vector is working on LIFO. I hope you have listened this word. It is called LIFO. LIFO stands for last in, first out. So if you have already some values, then the newly last value will be added at the end. But if you want to remove values from in, then the last value, last in value, will be removed first. Okay, so last in, first out. Okay, it's not like our daily queue management process, that the person who come first will be served first. No, here, if we want to remove, then we will remove the last item first, and to remove we have a separate function for that. I will show you that one in the next example. Okay, so for loop, and you see, in the same way, just calculate the grass pay and so on. So if you run it, it has the same output exactly like our previous example. Okay, next one, if we want to remove a value from a vector, then it will be what? Uh, okay, before removing, determining the size of a vector. You see, this is another difference from array. Array don't know about its size, but vector know about its size. This is just normal variable if you want to store the size. So any vector, in this case, for example, set that size. So it will return the size of this vector in integer value, integer format. Let's suppose the size is 5, then it will be here. Okay, so then you can do like this also, that you see, if you can find the size, then you can send array, you can send a vector to a function. Okay, and inside the function, let's suppose show values, no need to send the size of array. Okay, just you see, for int count equal to 0, count less than, you see, vector dot size, and then count plus plus. Array cannot do like this and then display the values. And this one is, you see, the same thing, vector int values, and now using for loop, we are pushing back seven values. Okay, and each value like count multiplied by 2. So first time is 0 0 multiplied by 2, second 1 multiplied by 2, 2 multiplied by 2, 3 multiplied by 2, until 7. And after that, to show the values, we just send the vector to the show function. No need to send the size. If you want to use the same thing in array, you will have to modify this function, and you will not only send the array, but you will also provide information to this function about the size of array. Okay, so it will, the show function, show value function is just using the size function and then displaying all the values like this. You see, 0 multiplied by 2, 1 multiplied by 2, 2 multiplied by 2, 3 multiplied by 2, and 4, and until 6. Okay, so this is another one. uh, I think I have created an activity for you. I think so. Yeah, let's try convert vector to array. uh, oh yeah, this one. Okay, this one, this example, can you change this example? Which one was that? Mm, this is example 728. Okay, the example 728, can you change to array? Let me change for you then if it is too difficult. Okay, so I will do like this, that let's save as this file, and I will give a name. Okay, now the point was that we need to convert vector to array. So you see, just this one, let me comment this one, and you see here I will create an array, int array. Its name is hours. Okay, and its size is okay, let me define uh, number of employees. Okay, I will define this one down, because when the employee variable get the values, then I want to put that one here. Copy, like this. So you see, this become now an integer array. This one is the same, this should be the same. Yeah, sure, no problem. This one, no problem. Yeah, just this one we will use instead of um, okay, instead of pushback we will just use here um, hours. You see the array and the index. Which index is it? It is, we will use whatever index value is it. Index is equal to the value that you got from user. Control Z should be here. Temp, copy this. Yeah, so this will be stored there. And after that, the same we will do, for this array also. Oh, we have two arrays. Okay, good. So we need to define two arrays, one with hours and one, this one, the parrot, and this one is double. Okay, so that one also I will define here. So double, the array name is this, and its size is also the same, number of employee. Okay, so this will be the parrot array. Now here again, instead of pushback, we will use this assignment, like parrot array and then index, whatever is the index in the loop variable, this equal to the value entered by the user. Okay, like this. And when we are going to display the values, okay, so here is okay, no problem, and grass pay, yes. You see, I think, you see, these were the only changes. So save it and run it. Oh, I think in the name I have given a space, and if you give a space, yeah, this is an issue. Okay, so let me just rename. Do I? Okay, can I rename here? Yes, rename. You see, here I have given a space, so I think no space. Okay, this one. Now save it and now run it. Yeah, you see this time. You see this time is running normally. I hope you can see now. You see how many employees do you have? Let's suppose 5. Okay, and now hours worked by employee 1 is, let's suppose, 3 hours, and its rate is 10 ringgit per hour. The other 4 hours and 20 ringgit per hour. 5 hours and 30 ringgit per hour. 6 hours and, oh, 60 hours, I mistaken. Okay, hours and pay rate is, let's suppose, it should have a pay rate less, otherwise it will get a lot of money. Hours worked by employee 5 is, let's suppose, 8 hours, and its pay rate should be 40 ringgit per hour. And you see all the values displayed now here. So I hope you get now what I did. You see, actually there was no big change. Just here was vector. I changed to array. Another vector, this one, the double parrot, I changed to array. And I only change here two things. You see, the pushback is for inserting a value. You see, add an element. So we can add element to array like this. So I just change this, and the same pushback, you see, I change to this one. So only 4 lines of changing. To remove an element from a vector, we will use pop back. If you remember, to add an element to a vector, we were using pushback. But here is pop back. So the pop back remove the last element from the collection. Okay, the collection is the vector name. So as I told you last time, that it works like LIFO, last in, last out. So the last element will be removed first. Then the second last element will be removed second, then third and fourth and so on. Okay, this example is showing that what the same. Let me open this example. This one is 28 or 29. 29. Oh my, sorry. Okay, if you see here, this is one vector. Its name is values. Its type is integer. The size is not known at the beginning because vector can be without size. So it's dynamically increases. So you see, we just add one value. Values that push back one will be added. Okay, it is like this, that we have uh, a vector. So when we call the pushback function, it will add one value here. Call again, another value will be entered here, which is 2. Call again, another value will be entered here, which is until n. So you see, there is no more. Then actually, its size will be only until this point. Okay, 1, 2, 3. Now, if you want to call the size function, you see, it will display the number 3, that its size is 3. And now, after that, we pop back. So we remove one item, and after removing the last item, if you display the values of the remaining two, it will display 1, 2. So, okay, we remove one item, and then we check the size again. Then it will be 2 restart. We remove another one item and check just the size again. So this time should be how much? Pop up, pop back, pop, yeah. This time should be 1. Okay, and last time pop back, so the last one will also remove, so its size will become 0. Okay, so it's work like this. So nice. You can't do like this in normal array. The size of value is 3, and then popping a value from the vector, the size become 2. Popping another one, the size become 1. Popping another one, the size become 0. Okay, so it works like this. Okay, so I hope it is clear. Next one. Hello guys, any also. Okay, last topic, that clearing a vector. If clearing a vector means that if you want to remove all the elements from a vector, you just call one function. You see, members dot clear, numbers dot clear. You see, dot clear is a function. It will remove everything from even though thousands of elements are there. So simply it will remove everything. And you see like this. You see here, it has 100 size, the values function, and if you check the size, it will display 100, and after that clear, and again if you see the size, it will be 0. So 730, let me quickly display this one. Run this one. You see a vector of size 100, and when we display its size will be 100, and after that clear, then its size become 0. So let's just quickly check. I will call the, you see, values element are 100. Okay, and after that a clear function, and the size becomes 0. So easy, no issue. Detecting an empty element, this is another function then that you can check. You can check the vector, that the vector is empty or not. If it is empty, you see, you just call the function dot empty, You see, this type of functionality is not available in array. In array, you will have to check each element one by one, that if it is empty, then you will have to decide on the basis of it. And in a function, now sorry, in a vector, you just check in if condition. If it is empty, then do something. If it is not empty, then you can leave it. Yeah. So let me run the last example also. You see a vector with the name values, its type is integer. Okay. And after that, how many values do you wish to average? You see that number, how many values to become average. Meaning to say you are interested to find out the average of how many values. Let's suppose 5 values. So you will enter the value, num values, the loop will go until that time, and enter the value and push back. Using this will enter the value to the vector, and after that average vector is a function, send the vector there. You see here average will be calculated. Average is, you see, the total will be calculated first, and after that the total equal to divide by the size. Okay, so in this way we can find the average, and after that, yeah, here is, check the empty. If the vector is empty, no need to do any calculation. Yeah, just return. Otherwise, else do the averaging. So you see, it's a very nice if else. If in case of array, if let's suppose the array is empty and you are applying this calculation, so you will get a random values. So that will be a strange result. So to avoid this, just call the empty function and then do the calculation.